Hello, my name is Mark Smith, and today I'm going to discuss how to use the A2-154 test jig software along with the test jig. The idea on the test jig software is that you can use the software to run all the switches and read all the indicator lights that are on the test jig, and you can do that from your computer. In the big picture, the idea will be that you can interface with another program like an audio analyzer to get a complete automated test set up. Here at Power Physics, we use a D-Scope Series 3 audio analyzer, and when we use that along with a version of the software, a little different version that I'm going to show you today, is we can hit a start button and run through all the tests in an automated fashion. But with another audio analyzer like an Audio Precision, where we haven't written the interface software, I'm going to show you how we can use this software, the A2-154 test jig software, to control the switches and read all the indicator lights that would be shown on the test jig itself. So let's go ahead and look at the setup. I'm using a webcam, so when I move things around, things are going to be a little bit noisy. Please bear with it, and I'll try to make this as smooth as possible. So let's go. I'm going to turn this around, and we're going to look at the test jig the test jig setup right now. Okay, hold on just a second. Okay, so that's our test jig, and you can see right here I got the A2-154 amplifier is attached, and we're going to turn on the power switch. That's the main power. I'm going to turn that guy on, and when we run the software on the computer, we want all these four switches in the down position. Okay, so we want them off. So that's that setup. You can see the audio inputs and outputs are going to our audio analyzer, and then of course we have our three cables on the A2-154. We have our power distribution, we have our speaker output, and we have our audio input signal. So now I'm going to move the webcam again to the computer screen that shows the A2-154 test jig software operating. Okay, so we have our test jig going, software operating, and hopefully you can see my mouse. Yeah, there we go. You can see the mouse. And what I'm going to do is I'm just going to go ahead and quit, and I'll show you how it starts up. When everything, I'm going to quit this thing, and it should be on your desktop, and in this case I have the test jig software right here, and in the same directory you got to have this MCC dynamic link library file running. That is necessary to run the software. So I'm going to go ahead and double click our little P2 test software, and it should come right up. Okay, so now those four switches we talked about before are located. We can control them actively with the computer with this one. There's 2, there's 3, and there's 4. Now we also have our LED indicator lights, and you can see them right here. They're all red right now because the unit is off. And then we have our amp disable light is currently green, but since there's no power, it really doesn't make any effect. Doesn't really. Anyway, it's green right now just because the amp is off. In addition to that, this little setup shows some neat things or status indicators for the test jig itself. It shows the plus and minus 43 volt supply and see what the actual voltage is. It also shows the 12 volt supply. In addition, it shows 3 different measurements that we can do on the amplifier that you can't do very easily anywhere else. And one is the offset voltage of the amplifier. It also shows the average current that's coming out of the current monitor pin on the amplifier. And then it shows you the temperature monitor pin, what the temperature is reading on the amplifier coming out the temperature monitor pin. And so let's go ahead and turn the amplifier on. In order to do that, we turn this guy's switch right there. And so as you see right away, we're getting our power supply voltages come up, and when you plug things into 120 volts AC, you get about 39-40 volts showing up right here. Our 12 volts is at 11.8, which is good. Our temperature monitor is showing that it's very, very cool. It's reading 4.3 volts and is reading 26 degrees Celsius. Offset voltage. With no audio input into the system, we're reading 10 millivolts on channel A and 11 millivolts on channel B. Actually, a negative 10 millivolts on channel A and a negative 11 millivolts on channel B. And then the average current is reading 0 right now with no audio input. That's expected. Okay, so we can enable the high current right here, and that shows, and you can see, what you see is that now the switch here, instead of saying enable high current, it says disable. So we can go ahead and turn it off if you want. We could disable the amplifier. Right now the amplifier is on. You can see the amp status is green. We can turn it off, and it turns off the amplifier. And of course, when the amplifier turns off, you can see the temperature monitor pin is no longer active. Turn the amplifier back on, and it comes on after a second. And then you can enable the overcurrent load. So as you can see, you can run all your test switches, monitoring right from this computer. And in conjunction with an audio analyzer, you can then do all the tests necessary to fully test the amplifier. I hope that's helpful. Let me go ahead and turn these things off. I'm going to disable the supply, and everything drops back down. Yeah, I hope that's helpful, and we'll be back later for possibly more instructions. Thanks.